Kia ora. Welcome to this second part of the lesson with coordinate geometry, where we're going to be finding the equation of the perpendicular bisector. So, in order to find that equation, you're going to need two things. That is a point on the line and the slope of that line. And those two things make up what's known as the point-slope equation of the line. And here it is. It's y minus y sub 1 is equal to m times the quantity x minus x sub 1. Now, as I said, you need a point on the line, and since there's only one point needed, that's why it's x1, y1. And we know the slope is m. Now, we're finding the perpendicular bisector of the line segment AC. I like the point C because it's the point 1, 1. Easy numbers to work with. You could have also used point A, but that had some negatives and other numbers, so I chose to use 1, 1. x1 is 1, y1 is 1, and our gradient is negative 5/3. Now, substituting these values into this equation, x1 is 1, that goes there, minus 1. So again, remember, it's minus the x1. x1 is positive, so it's minus positive 1. The y sub 1 is also 1, y minus y sub 1, and the gradient negative 5/3. Now what we're going to do is we're going to simplify that equation. First step is get rid of the brackets. Brackets mean to multiply. Negative 5/3 times x is negative 5/3. Negative 5/3 times negative 1 gives us positive 5/3. Continuing to simplify, we want to get the y by itself. To get this into y equals mx plus b form, how do you undo the minus 1? You add 1. 1 would be 3/3. Added to 5/3 is 8/3. So this is the equation of AC. Now, what we want to do, we want to find the equation that was the perpendicular bisector. And one thing we talked about in class is that perpendicular lines have gradients that are opposite reciprocals. So if the gradient of AC, line segment AC, is negative 5/3, well, perpendicular lines are opposite in sign. So if this one's negative, the perpendicular one has to be positive. And when I'm saying they're reciprocals, 5/3 has the reciprocal of 3/5. So as I said, since the gradient of line segment AC is negative 5/3, the perpendicular gradient is positive 3/5. What we're going to do now, we're going to use D, which was the midpoint of AC. You know how to calculate midpoints. The midpoint is negative 0.5, 3.5. This is, again, that was my x1. 3.5 is my y1. And we know that the gradient was 3.5. You will once again use the point-slope equation. You'll substitute into the equation just like you did before. My y1 is 3.5, y minus 3.5. My gradient m is 3/5. There's the gradient. X minus x sub 1. Now x is negative 0.5, so this is x minus negative 0.5. Now we should know that the minus of minus turns into a plus. We're again going to use our algebra to simplify. The brackets mean multiply. 3/5 times x is 3/5 x. 3/5 times 0.5 is 3/10. You can use your calculator for that. Now we want to get the y by itself. We're going to undo the minus 3.5, change sides, change operation. So we'll add 3.5 to both sides. And that gives us, this is the equation of the perpendicular bisector. Y is 3/5 x plus 3.8. Now, all you need to do is give this equation in one other form. And that's going to be this form right here. You're going to change it into ax plus by plus c equals 0. This is the other required form. So a needs to be a whole number, not a fraction. 3/5 is a fraction. Since 5 is the denominator, you're going to times everything in there by 5. Timesing everything by 5 gets rid of the fractions. 5 times y, 5y. 3/5 times 5, 3x. And 3.8 times 5 is 19. Now this is really, really close. The coefficient of x is 3, and it's positive. So this stuff can stay right where it is. We're just going to bring this 5y over from the other side. And that's going to then give us 0 because the 5y is subtracted from both sides, leaving 0 on this side. We have 0 is 3x. 0 is 3x minus 5y plus 19. And all you're going to do now is rewrite this in this following form. 3x minus 5y plus 19 equals 0. Reason we can do that, why this is the same as this, well, are these two things the same? Yeah, they're exactly the same. Well, if I do that, are they still the same? Yes. That's why this equation is the same as that. That's going to be your working towards excellence. For a little extra extension, I want you to try one on your own. Find me the perpendicular bisector of BC. Thanks for watching. Mauri mahi, mauri ora, ka kite ano.